Thank you very much to Anna Cumming and all of the participants of our last session. Some super interesting conversations going on in the chat and really great questions coming through on that topic. Before we move through to our next session, we'd like to let you know about our current Renew member prize draw. Renew being the organisation that runs Sustainable House Day each year. We also publish two magazines named Renew and Sanctuary Magazine, and anyone who subscribes to these magazines by 5 p.m. Australian Eastern Daylight Time on Monday the 29th of November will go in the draw to win an Earthworker Reclaim Heat Pump Hot Water System, and that's worth $5,000. It's from Earthworker Energy Manufacturing Cooperative. And you can go to sustainablehouseday.com/subscribe to sign up to either or both of those magazines. Of course, all of our current Renew members and subscribers are automatically entered into that draw. Next up, we have a session on using solar energy. This session will be emceed by Damien Moyse, who is currently a Senior Policy Officer on Gas Reform at the Department of Environment, Land, Water and Planning. And he was formerly the Policy and Research Manager for us at Renew. So I'm going to hand over now to Damien for our next session.
Thanks very much, Erin. Nice to see you. Nice to see you all. Yes, my name is Damien. I'm a former staff member and still current member of Renew, and very happy to be here with you all this afternoon. And yeah, to welcome you to this session, which is running on sun, using solar energy at home. So before we get into it, just like to acknowledge that I'm coming to you from the lands of the Wurundjeri people of the Kulin Nation. I'd like to pay my respects to the community's elders, past, present and emerging, and you might like to pop in the chat where you're tuning in from for this session. Yeah, so this session is using solar energy at home. We're going to hear from 4 homeowners who have made solar energy a part of their daily lives. Now, it's worth noting that in terms of solar electricity, it's always been a pretty big focus for Renew, the organisation. Actually, a big part of the reason that around a quarter of Australian households have solar today is because back in 2005, Renew actually wrote the first set of guidelines on how to connect a solar PV system to the electricity grid. So for many people who have solar at the moment, we can all be thankful to Renew for that. No doubt many of you tuning in have solar at home at the moment, so you also might like to pop in the chat what solar system size you've got, or when you installed it, or maybe what price you're getting for a feed-in tariff, and we can get a bit of audience participation. So I think it's time to introduce the 4 panelists. They're going to give us a brief overview of who they are and their experience with solar and what they've been up to, and then we'll kind of get into the Q&A component. So first panelist is Alan Leenaerts, and Alan's house is named Alan's House on the SHD website. I believe Alan's house not only has solar, but is rated at 10 stars and has lots of other different and interesting sustainability measures. And I might pass over to you, Alan, to talk to us a bit about it.
Thanks, Damien. I started off my house with the standard 1960s era cream brick veneer, and then did a modification, which you're looking at now. You're looking at the new front. It's 4 rooms built across the front. So when I renovated and extended, I had good opportunity to retrofit lots of low energy features, which we normally show on Sustainable House Day. But today we're only going to talk about solar. First thing I want to say about solar really quickly is that so all energy on this planet is solar. That's where it all comes from. Even the fossil fuels in your cars, it was originally solar energy. Most people are familiar with solar PV. Not everyone's familiar with heat pumps. Not everyone's familiar with ground source geothermal or shallow geothermal. And not everyone's familiar with solar space heating, direct solar space heating or active space heating, which I've all incorporated into my house, and hopefully I'll be able to speak to in more detail. There's articles on this in past Renews, so issue 123 and issue 155, if people want more details on the solar space heating, which to me is the forgotten solar energy, and reduced my heating bills by in excess of 95%. So is that a minute? Am I done?
Yeah, I think that's pretty good, Alan. Thanks very much for that. Yeah, our second panelist is Howard Elston, who has the Green Home Build project or home on the SHD website. I understand that's a recently completed home that was a finalist in the 2021 Sustainability Awards. So congratulations to Howard from that. And maybe you'd like to talk to us a bit about it.
Okay. Thanks, Damien. Yes, as you mentioned, it's a new build. So that gave us the opportunity to actually work from both sides of the energy balance. So it's a passive solar design. So the first thing we're after there was to minimise the amount of energy we needed for heating and cooling. So that was a primary focus there. And then we went all electric with the house. So we packed it with high efficiency devices, for example, using heat pumps for heating and cooling, heat pump for hot water system. So the idea there is to get the most effect we can from the electricity that we do need to run those devices. So on the consumption side, trying to minimise our consumption, and then look at the production side, and that's where the solar panels come in. So we've gone for an 8 kilowatt system with a 10 kilowatt battery connected to it. And that's what gets us through most days, running on solar, essentially. So looking forward to sharing that experience with people here at the session today.
Great, thanks, Howard. Now, just to remind people, pop your questions in the Q&A part of the Zoom window, and we'll start to deal with those in a moment. I'm going to pass over to Richard in a moment, who is from Harmony House on the SHD website. So also, I think this one may be a relatively recent build, and kind of interesting because this actually has an off-grid solar and battery system. So over to you, Richard, if you're there to tell us a bit about it.
Yeah, so our goal from the outset was to create as energy efficient as possible while still being affordable. And it was quite a hard balance to achieve, actually. I spent years sort of looking at every option under the sun, it seemed like. But the solution for us came when we stumbled across the Design for Place passive solar plans, which were part of the Your Home initiative. And that's turned out to be an absolutely fantastic design, really energy efficient, but also affordable to build, just using all sorts of the normal standard building methods. And yeah, we found that energy efficiency has been the backbone to opening up all sorts of other options for us. And as you mentioned, the off-grid opportunity, because being in Victoria with Victorian winters to deal with, if your house isn't energy efficient, then an off-grid system probably isn't a viable option. But with an energy efficient house, it is. So we generate all of our electricity from the sun, and it's an all-electric household as well. Being grid then actually opens up sort of further opportunities just because it sort of puts the numbers in your favour when you're trying to make decisions about other things. So for example, we were able to install a robot lawnmower that does all of the lawn mowing for us. So no fossil fuels used there. And it's because our off-grid system takes about 2 minutes, even on a cloudy day like today, to generate enough energy for 10 hours of mowing. So it just puts the numbers in your favour. And a similar example, which really blew my mind because I thought there was no way we'd be able to afford an electric car after spending all our savings on the build. But when I crunched the numbers on that, again, being able to charge the electric car with our own energy just put the numbers in our favour, and we've been able to go in that direction as well. So for us, it's been really interesting that energy efficiency from the outset is what's been the backbone to allow other sustainable choices to be made.
Great, thanks, Richard. And last but not least, we also have Martin Ander, who is from Djildjit. Now, Martin, please correct me if I've pronounced that incorrectly. I understand, Martin, your project comprises 2 one-bedroom apartments. So kind of keen to know how the solar setup works for that site. So Martin, if you're there, please tell us a bit more.
Yeah, good morning, Damien and everyone in the East over there. Yes, I'm here at WGV, a village in Fremantle, Perth, and there's 2 main components, I guess, I wanted to highlight. Is that first of all, our home, and that's 2 apartments on the one lot, is part of a village microgrid, solar microgrid system of about 30 lots in this development. And that was also run as the world's first solar microgrid peer-to-peer trading program a couple of years ago, not long after the village was established. And then secondly, my house, or I should say the 2 apartments, which are running a 5.5 kilowatt shared system. That whole development of 2 apartments is run as effectively what I call a thermal battery. So as you can see in the photo there for Djildjit, there's a lot of mass. So it's quite heavy thermal mass, and we're running a shared heat pump system, 3 kilowatt electrical capacity and about 11 kilowatt heating cooling capacity. And this is what drives the heating, cooling and hot water for both apartments, a 3-in-1 heat pump. And so that we can program that, and the way we program it is that to run during the day on the solar, so that we're not exporting all of our electricity to the grid, which we only get 3 cents a kilowatt hour for. And in the middle of the day, it's not needed in this area. Anyway, we've got a very high penetration of solar in this part of the world. So that's it. There's 2 key standout elements, I think, of this solar system. One, it's part of a village solar microgrid where a peer-to-peer trading trial was run. And then secondly, it's a solar system that is part of the house as a thermal battery. Thank you.
Great, thanks, Martin. Very interesting. Okay, well, let's get into the Q&A section. So for everybody who's listening in, please, pop your questions in the Q&A box, and we'll try and get to as many as we can over the next half an hour or so. I'm going to start with a pretty general one for the group. It's always tricky, kind of, I think, when you're sort of starting off about thinking about solar and who you should go with and how you should sort of go about the process. So how did you guys make the decision about which solar supplier to go with, and sort of how did you find that process in relation to kind of getting quotes and assessing them and all of that? If you could talk to a bit of that, that'd be great. Don't know who wants to go first.
Well, the answer from me, Damien, is pretty easy. I didn't have a choice because we were part of the village was developed by the state government agency Landcorp at the time, now called Development WA. And so there was a tender selection process for the solar provider, because the way the village was set up was that everyone got like a $10,000 like handout bonus if you built there. But with that $10,000, you had to buy a solar power system, a rainwater tank, and 2 deciduous trees from the suppliers who'd already been selected by tender. So we purchased ours from Infinite Energy, and now that's owned by Sumitomo, and we had no choice at the time. But anyway, it was a good service, and we were very happy with it. Thanks.
Thanks, Martin. Other gentlemen?
Yeah, a bit of background now. I suppose we worked with our electrical contractor on the new build and relied on his trade experience, because he's done, well, he got a lot of experience with it. So we relied on him to go, okay, what works in the industry? What is the industry saying, rather than just a particular supplier? And he was able to point us in the direction of the system that we installed based on his experience.
I think it's a really good question, actually. I did a similar thing when I was looking at every part of our build. So I'd find out enough about it myself to be a relatively informed customer. And then I'd get quotes from multiple different people. And I'd often have, I guess, sort of telltale questions to ask. And that would give me an understanding of what angle they were coming out, or coming at it from what level, because everyone has different experience. And that method worked really well when choosing our supplier, because I think particularly with solar, you can get some, smaller operators that have just come from being a house electrician, for example, and have moved into solar. But when I did my research, the ones that I found, Off-Grid Energy Australia, they were real experts, not only in hybrid systems, but in particular off-grid systems. And they've been doing them for years, I think a decade or so. And it was really, really clear when I asked my questions that they had a level of knowledge that was just far superior to anyone else I contacted. And so that was my duty of care there. You know, I couldn't go through the learning curve to design the system myself or to become an electrician, but my duty of care with research was to find the best people for the job, and they really hit the nail on the head there. And I can remember a article in a Renewer a few years ago that actually looked at people that were living off grid, and some case studies basically of where it's gone right, gone wrong. And the takeaway message that I took away from that was that people that have been living off grid and enjoying it, you know, where it's been successful, generally have had their systems designed by a professional. Whereas people living off grid that have trouble sometimes and, you know, may run out of energy and things like that, it's been more of a put together sort of thing. So for us, it was really important to get real professionals to do it. And we've been so happy with the result.
Yeah, great. Good to hear. Good story, Richard. Alan, anything to add to that?
Yeah, well, my answer will be in some parts because we've only had answers about solar PV. And I've installed 4 PV systems. The first one was, and there's an early adopter in 2007, 8 or something, and there wasn't any choice. You just install what you've got. The second system, second grid interactive system, I installed with Origin, and that was purely because they were doing the best deals on the grid interactive battery. The third system I installed with a mate because he was an electrician, and that worked well, and that's an off-grid system. The fourth system, the fourth system is solar hot water. We forgot, no one's mentioned solar hot water. And I went to, because I have a heat pump boosted solar hot water system. So I got the gold standard. There are very few people that are doing those systems because they're quite pricey. So I went to one of the only people that were installing heat pump boosted solar hot water evacuated tube systems. The fourth system I installed was a solar space heating system, and I built that myself because the ones you buy are prohibitively expensive, and to build a system of my size, which is 50 kilowatts, it would have cost me about $75,000, and I built it for $1,000. The fifth system, which is the ground source geothermal, shallow geothermal, which is technically solar energy, I built myself because for the same reason, no one's building them, and anyone that would even contemplate building it would have charged prohibitively, and I built that for $500 or something. So a mixed answer. Now, if I was going to build another PV system, if we're only talking PVs, but that's only a small subset of solar, if I was going to build it, and again, I'd just make sure I didn't go to a shonky operator. Go to the biggest organisation you can, because they'll be the most accountable to the ombudsman if something goes pear-shaped.
Yep, it's a good point. Thanks, Alan. So lots of questions coming in for you all. We'll get into some of the list now. So perhaps a quick one. We have solar panels. Can we put a battery on now? Is it affordable to do? We have a 6.6 kilowatt solar system. And what battery size do you need? Anyone want to tackle that one?
That's a question for a specific solar expert, for the person who you're buying the battery from.
I suppose the first thing I'd ask is about the inverter, because if you've got an existing solar array plus an inverter, you'd have to ask yourself the question, is the inverter capable of talking to a battery? Because you might find you're not only up for the cost of a battery, you also need to upgrade your inverter as well. So that would affect the economics of it.
Yep. Any other points on that question?
Just that you're definitely up for a new inverter. Very few inverters that are installed are going to be battery compatible.
Yeah. So there's an issue there with, you've got a heritage system. In terms of battery size, really you're just down to, you've got your standard size. I mean, the LG Chem sort of 10, 13, Tesla sort of 15 or so, and then it's how many do you want? So it's really a question of evaluating your consumption, and is it better to work the reduced consumption side rather than putting a whole bunch of batteries in to keep your house going when the sun's not shining? So as Alan's pointed out, there's actually a fair bit of work needed to go into that to try and figure out the cost side and also, what you can afford to put in.
Yeah. And a little follow-up question there was just, what are the benefits? I mean, you've sort of talked to them, but what are the main benefits of installing a battery with your solar system?
Well, I think still connected to the grid, because Richard's probably got some comments there about being off grid, which is a different situation. Being connected to the grid, I had 3 reasons why I did it. One was to use solar at night so that I can ride through. I'm not pulling in power off the grid at night time. The second one was just energy security, because the number of maintenance outages and the number of failures we're getting these days are increasing because our system is quite old and creaky, so you can't rely on it the way you used to. And the third was just to have something I could learn how to use, because there's all sorts of tricks you can play. If you've got the right sort of inverter, it's not just having a battery that sits there static. You can run your own power system and you've got your own power station. So I can import and export when I want to, when I've got a battery. So I'm not relying on the grid to tell me when I need to import. I can pull in off-peak power at night and use that the next day if I'm not generating enough off my solar panels. So there's an extra layer there. When you've got a battery, you're not totally just solar, and when the sun stops, that's it. I need to run off the grid. There's extra things you can do. I suppose, Richard, you have comments there about if you're totally off the grid, I mean, what a battery can do for you there.
Well, exactly. Yeah, certainly need batteries when you're totally off the grid. That's where all the energy gets stored. And Off-Grid Energy did such a good job with the system. They do generator-free systems. So we don't have a grid connection, nor do we have a generator backup, but it's such a great system with depth that, we don't need even a generator backup. And I think that goes a little bit to the question just before. And my sort of response to that is that a system needs to really be in balance. The number of solar have compared to what your solar inverter rating is, to your house inverter, to the size of your battery bank. If it's something I've learned, it's that balance between all the elements of the system is really important. And I think nowadays they tend towards oversizing the solar arrays so that you can make more energy even on cloudy days. Whereas in the past, they used to, for off-grid systems, oversize the battery bank. But now, because the solar panels are so much cheaper than batteries, you're better off oversizing the solar array than the battery bank. And that certainly comes through for us on days like this. We've still got, I think, even now, 6-7 kilowatts coming in from our 14 kilowatt system, even though it's very, very cloudy. So yeah, again, my point of view, balance in the system is really important, and getting it designed right to begin with, I think, is really important.
Thanks, Richard. Alan?
I was just going to say, I have 2 battery systems. One's grid interactive, one's off grid. The grid interactive system I bought because A, it was cheap because it was subsidised by the state government, and B, because it's interactive. So we support the grid, and it buys and sells automatically and generates me money. So it's one of my income streams at the moment. The off-grid system is purely to run the house on. So I can run off-grid. So I have about 7 grid interactive and about 3 kilowatts dedicated off-grid. My advice to anyone that's considering a battery is don't buy a car, buy a grid interactive car, because the battery is 100 times cheaper. It's 10 times bigger. And unless you've got money to burn, buy an electric car. So my electric car sits out there. It's got 60 kilowatts. Not only does it provide me transport, but this one doesn't, because I bought too early for it to be grid interactive. But if it was grid interactive, 60 kilowatts grid interactive, if you arbitrage the system, you can retire. And that's the big hurdle at the moment. So that would be my advice. As much as it's a great thing to buy a battery and support the grid and help the transition to a green energy, if you're talking purely about economics, don't buy a battery. They're really expensive. Buy a car. I think Nissan are currently doing a grid interactive one. Tesla are about to do it. I think the next generations of Kona are about to become grid interactive. But that's the future. Grid interactive car, big battery, make your money, That's what I do.
Yeah, I think we are coming to that point where people are considering whether or not, the household battery or the EV and how they're going to, make those things kind of work together or prioritize into the future, because the EV thing is happening.
10 kilowatts, so in total 20 kilowatts, whereas the car's 60.
That's it.
I can make $5 a day just by arbitraging the electricity system.
That's it. Now, Martin, I'm going to put you on the spot here. We've got a lot of interest in this 3-in-1 heat pump. Many questions around that. So, just basically, could you tell us a bit more about what the system is, how it works, and we might have a bit of a focus on heat pumps generally for a few questions.
Yeah, look, I think all of this is a really interesting conversation, so it's great to hear what's going on. But yeah, this 3-in-1 heat pump system and trying to design and develop and run this house as a thermal battery has been really interesting. I would have loved to have got a battery, by the way, just for, I guess, for being a tech nerd. But like Alan says, that it's just too expensive at the moment. But I just love this idea of the new electric cars coming in, and I think that will be our way to get into, just upgrade the inverter and plug in the new car one day without actually having the battery on site here. And that would then still allow our house, I guess, to run as intended, the thermal battery with the 3-in-1 heat pump system. So the way we set that up is quite interesting, actually, because I teach environmental engineering at Murdoch University, and one of my graduates, he did his final year project on geothermal, but in the end, of course, he just was looking at shallow geothermal for heat pumps, and designed one for a school, and then later got a job with a company called Direct Energy, and he flies it all around Australia now, putting in these large heat pump and ground source and air source and hydronic systems all around Australia. He's been doing that for about 5 or 10 years now, and he's just become a real expert. So he actually worked with me and designed that system, and we selected the system components for that. And so basically what you've got is because we've got 2 apartments, and we've got one shared heat pump for both apartments, and one shared 5.5 kilowatt solar power system. And so what we've done, sorry? Oh, I thought
you're right, Martin.
Yeah. What we've done is it's 2-story development, split down the middle between 2 apartments, and in the ground floor slab, Max and I laid the plastic tubing ourselves, tied it to the Rio mesh just before the concrete was being poured, and then after the concrete's poured and the building's built, we then in each apartment was set up separately with a separate control system. So then we brought the header tubes, the common tube in each apartment, back to a manifold, and then so each apartment had its own manifold and solenoid valves, and then we piped all of that back to the heat pump at the shared garage out the back there, and all insulated. And then and so that can run the heat pump, being a 3-in-1 heat pump, can then provide that ground floor slab hydronic tubing with heating and cooling. And I tell you what, it's damn nice in winter when it's freezing cold outside and you like doing a bit of yoga in the morning, and doing the yoga on a warm slab. That's a real bonus. And then in summer, of course, it can be running cooling mode. And so we can either run it through the slab downstairs, which is pretty nice actually, and then we've got a fan coil unit each upstairs, so we can actually pipe the hot or cold chilled water to the upstairs fan coil. And the fan coil unit we generally only use in summer, and because we've got ceiling fans as well, actually, because it's a passive solar designed home, I find the house actually works probably better in summer than winter from a passive solar point of view, because we couldn't get as big as north-facing windows as we would have liked. So in summer, we don't run it a lot, except on those really hot days, 40, 45 when we're working from home. But even with the ceiling fan, I mean, I really like heat anyway, so I very rarely run it. But I think generally we run it a much smaller amount of time in summer because we've got the ceiling fans too. And I think overall, I was looking at the grid energy retailer billing records recently, and across the whole year, we're running at about on average about 5 kilowatt hours per day per apartment, or 10 kilowatt hours per day for both apartments across the whole year. You know, it varies a bit, of course. And then, of course, in winter, which is when the heat pump is used mostly for heating, because what we do actually is we've programmed it so it just runs during the day. We try not to run it at night, so that therefore we're mainly using solar electricity to run the heat pump, and then so in summer when we don't have so much cooling demand because the house works quite nicely with all that thermal mass, we actually export quite a lot to the grid from the 5 kilowatt system. So that's in it. Yeah.
We might just take a step back too, if we can, Martin, or any of the other panelists. Just can we explain to the listeners, just in basic terms, what a heat pump is? Does anyone want to have a go at that?
Well, I'm happy to give it in really basic terms. It's basically no different to you know, a split air conditioning system or a fridge. You basically just like in any of those devices. You've got your condenser side and your evaporator side, and basically if it's a split system, for example, the heat pump condenser part is a unit that sits outside, and that's a compressor and a motor, and that's you know, it's using a refrigerant liquid, or these days CO2 gas if it's a more eco-friendly version, trying to get away from all those different old style. What were they called? CFCs. And
refrigerants.
And then and that's then pumped through an expansion valve and up to the fan coil unit, which is the evaporator side, and you know, and then you're creating heating and cooling on that evaporator coil. And
very efficiently. I mean, you know, lots of countries around the world, you know, call reverse cycle air conditioners heat pumps. We call them reverse cycle air conditioners, but they're the same thing.
Yeah. And of course the heat pump hot water unit. I mean, a lot of people these days have got a heat pump hot water unit. So there's that's probably along with the split conditioners and the fridges. That's another very common application. So ours as a 3-in-1 heat pump is a hot water system as well.
Now, Alan, looks like you might have something to add to that.
I was just saying I've got 2 heat pump hot water systems.
I think the key thing to remember here is that the heat pump uses a small amount of energy to move a large amount of energy. So you might have 1 kilowatt of electrical energy going in, but you're getting 4 kilowatts of heating or 4 kilowatts of cooling, which is a massive difference to, say, a gas ducted heating system, which is flipped the other way around. So the efficiency's amazing on these things. And with a heat pump, it's renewable energy. You're using energy from the atmosphere, and you're just moving it either inside or outside your house or into your hot water system.
Yep.
And if you might be able to run it more during solar generation times, and if your home building is relatively efficient, you can do a bit of preheating and pre-cooling, and can work quite well. Now we've got quite a few questions coming in around 3-phase. So let's get into the technical side of things. Anyone want to have a go at explaining 3-phase versus single phase? Not the concept, but in the way that I guess it relates to solar. People are asking, you know, should they be considering 3-phase? Is it advantageous for EV charging, for example? Is there much of a price difference? Does anybody have a 3-phase setup?
I'll start. I guess I'm the one with the EVs on solar. In the first instance, I'd say 3-phase is not useful for most people living at home. And the only exceptions would be for people who need to do welding, need lots of current, or for people that are doing 1,000 kilometres a day and need to fast charge their car so they can shoot out again in an hour's time. I comfortably snail charge the Tesla and the Kona And we've never been caught out with range because they sit there overnight for 12 hours anyway. Three-phase is something, if you had an industrial strength air conditioner, you'd need three-phase, welding and fast charging. If you don't have any of those three things, I can't see any reason you'd need it off grid. The others could correct me if they've got it.
Yeah,
Well,
anyone else with views on that?
Yeah, I think you're right there, Alan. It's around if for your standard house, single phase is fine. It would only be if you felt yourself in a situation where you needed to have one or two electric vehicles and you wanted to turn them over pretty quickly, you might need a three-phase system to fast charge them overnight so that you're ready to go again the next day. That, to me, that would be future-proofing your house, where in the future you couldn't rely on chargers elsewhere in the neighbourhood where you could drop in and fast charge. You had to do it at home. So three-phase would enable you to set up a system that you could run a 22 kilowatt or greater charger, but that's not currently the case for most people.
Great.
Just not necessary.
Yep.
Any other comments on that one? Got a fairly straightforward question here. What's a reasonable life expectancy for solar panels, or does it vary?
They keep it 25 years. Usually.
25 years.
25 years to 80% is my understanding. But they reach output over time.
Yeah, and probably worth noting too that that's for the panels, but of course with the inverters, they typically last a little bit less time. Not sure if the panels had experience with inverters lasting a long time or a short time, or have had to deal with replacements in that context.
Yeah, we had one of our inverter failed within 12 months. That was just I don't know what went wrong with it. One of the internals failed, but it's a solar edge inverter. They were really good. They just admitted there was a fault with it and we just got it replaced. But I think it's the standard, is it the duck-shaped curve where in the first 12 months you might have something going wrong and then they should settle in and just last forever. And then towards the end of their life, you'll start to see failures pop up. But I think it comes back to the brand again. I mean, you can get cheap inverters, you can get cheap solar panels. And I think what's happening there is you're paying for longevity. You know, they probably won't last as long as some of the other ones.
My take on it is that the technology is moving quickly. You will replace it before it breaks from age. So I've already replaced my original inverter, not because it was broken, but because it was obsolete. And I wanted to change my original 1 kilowatt system to a 7 kilowatt system that was grid interactive and can do all sorts of other sexy things with power that the original systems would just couldn't do. And if anyone wants it, they can have it, but it's sitting under the house still. Like I say, they survive the first year, they'll survive 20 years. They're pretty good.
Yeah.
So one thing that I liked about the company that installed our system is that they go to a lot of trouble actually research the different suppliers for the components they use, just to make sure that, you know, the warranties will be honoured and that the companies, you know, will be around for the distance. And there was one particular test that they did on each company. It's a common one. I've forgotten what it was, but it basically gives a rating of how likely that company is to go out of business in the next 10 or so years. And I jokingly asked if they'd do that for me as well after all the spending I've built. Yes, I wondered myself if I was going to be viable for 10 years. But that gives us a lot of peace of mind in our system that everything does come with a good warranty and good solid companies behind the components.
Yeah, thanks, Richard. That's good advice. Okay, is a bigger solar system size better? I'm building it on a 2-acre property in Country Vic and wondered, should there be a difference between a PV solar system for urban or sort of for a rural situation? Any advice on that one?
Depends what you're using it for. Absolutely, how big your family is, whether you're on grid or off grid, whether you're planning to have electric vehicles or not. So that's the first step that installers usually take when designing a system for you, is to do a load profile for you based on, you know, your last couple of years of energy bills to see what you use and how you use it. And yeah, it really should be a tailor-made solution for where you're living, how you live, and your particular family needs.
Yeah,
And,
any other comments on that one?
I think it also comes back to the house design as well. So being in a position where we could design greenfields, we tried to minimise our energy consumption. So we weren't fitting a solar system onto an inefficient house, which that can be a major consumer. So one of the things to look at first, I think, is if you're using a lot of electricity, where's it going? Is there any way you can reduce that? Because you can reduce your consumption, then you don't need such a big PV system to get you through.
My response would be no one ever regrets getting a larger system. People often regret getting smaller systems. Notwithstanding your advice, Howard, is still the best.
Yep, that's the electricity you don't use costs the least.
Yeah, no, good advice.
I'm just wondering as well, Damien and the others all over east there, we have a 5 kilowatt limit to the inverter size you can connect to the grid here in the southwest, around Perth. So I'm just wondering, is that different over east?
Nope. In fact, in some areas it's less than that. It depends on your grid system. So I know in the western parts of Melbourne here, you're down to sort of 3 to 3.5 in some of those areas. So we're stuck with a 5. So on a sunny day when it's pumping, it's like anything you can think of, just start using. The dishwasher goes on, the washing machine goes on, the car's being charged, anything to use those electrons.
This is where I think, well, I guess too, how that's probably going to be in summer when you're really pumping it out. But this is where I think the houses with thermal battery comes in as really, really useful, and in either winter or summer, and combine that with passive solar design, and you've really got a powerful force there. And the third thing I combined it with here is all the concrete and rammed earth walls on the ground floor are made from recycled construction demolition waste. So, this is one of the big failings in Perth. I know you're a lot better over east there, but we only have about 30 or 40% recycling or recovery of construction and demolition waste. And we're largely a masonry style construction city here, whereas I know over east you're largely a lightweight timber frame construction. We're slowly transitioning that way here. We've got some great companies that are doing it to get up to even a passive house standard, but we're still largely a wet construction. And so with that technique, this is still where it's really important both for new builds and, getting in a house as a thermal battery, in the concrete slab, and you've got all that brickwork that can store the heat. And but also as our city transitions, and we've got only 30% recovery of construction and demolition waste on average, but we need to get up to the state government policy target of 80% by 2030. What are we going to do with all that construction and demolition waste? Well, at the moment, it's all sitting in massive stockpiles because the builders and the demolition contractors, they don't want to take it to landfill because they get whacked with $100 a tonne or cubic metre landfill levy. So they stockpile it everywhere on cheap land. All of that can be getting converted into building blocks, rammed earth constructions. There's so many applications which I've demonstrated here in the house and with some other colleagues around the place. And then you whack in your hydronic tubes into that and connect a heat pump to it running on solar, and you've basically got massive thermal battery. And in Western Australia, at least, I just think we should be doing a lot more of that. I guess over east it's a bit different because you've got a lot of lightweight construction, but still you've probably got quite a bit of concrete slab going on. And even into the concrete slabs, you can pour in lots of recycled material. So I think that's a big opportunity.
Thanks, Martin. Question here around maintenance, which might be an interesting question given that we've got both kind of grid connected and off-grid systems on the panel. So how much does it cost generally to maintain solar panels and batteries? And I guess a key part of that is how might it differ between grid connected and off-grid systems? Anyone want to have a go at that?
It costs me about half an hour with a mop and a bucket about once every 5 years.
that's if you've got a good system that's installed by a reliable electrician, There's really no maintenance at all. That's my experience. The occasional cleaning off the panels if there's too much sap or something from the tree next door, or the birds have been having a go at it. Or we get one of those dust storms come across and the poor old mallee loses all its red dirt onto my roof.
Well, Alan's mentioned there, you know, maybe once every 5 years, but I don't know whether I'd have to do it ever, because what's happening here in the southwest with climate change is we're not only getting reduced rainfall, but when we do get rain events, they're pretty well much higher intensity. So what it means is you get a really damn good downpour and you really get your solar panels well washed.
Mm.
I've found that I have to wash off the mold on the flatter panels. So if your panels installed less than 22 degrees, the water will sit on it long enough for mold to slowly grow. And when I say slowly, once every 5 years. Whereas steeper panels will wash clean so that nothing ever grows, and they're absolutely clean, bomb-proof. That's just my experience.
Yeah, thanks, Alan. Lots of questions around EVs and I guess their sort of relationship with solar. So I guess one of the ones that keeps coming up is when am I going to be able to run the house off the EV?
We can now. Nissan already do it. I think Tesla have enabled it in the States, but not here yet. All it takes is a software download from Tesla. So if you've got a Tesla, then you just cross your fingers and hope. But most of the major car manufacturers are looking at this. I'm no expert in this, but I know that I've seen announcements. They're all planning to do it because it's a no-brainer. When we lose Morrison as a Prime Minister, probably. Yeah.
Any other thoughts on that one? I think there might be a follow-up one there for you, Alan, which is just, I think you talked about snail charging before. Do you need a specialised EV charger or is the standard
10 amp GPO? And because most people sleep overnight, unless you need a rapid turnaround of your vehicle, anything beyond a snail charger is unnecessary. I looked at putting in a semi-fast charger. I think it's the intermediate 7 kilowatt system. It's going to cost $1,500 or something, two grand, and couldn't justify the expense because it charges overnight. Every time I go out there, it's fully charged. I've got 450 k's of range, but I can't use. You know.
And I definitely agree with that for an on-grid system that you can, charge overnight just by the 10 amp power point, and you wake up to a charged car every morning. For us here in an off-grid system, we want to use the sunlight. So for me, grabbing the available sunlight, it was worthwhile putting in a charger. So we just put in the standard Tesla charger, which I think was $780 for the charger, but then install costs so ended up being about $1,200 for us. But it is just gold for us because when the sun is shining, I can grab energy at 5 times the rate of the snail charging, and that's really essential for us to manage our kilometres driven and our household needs as well. When the sun shines, you've got to make hay when you're off grid. And that brings up one thing that we sort of haven't touched upon and gets a bit into that maintenance question. And I agree, there's no general maintenance needed. But living with PV systems, especially off grid, but grid connected as well, it does actually bring you closer to the environment and nature every day. Like I'm looking out, always sort of judging what type of day it is, how much energy is going to be available, and making decisions based not only on the day, but different parts of the day as well. So it's actually, a really fun game to play, and yeah, really sort of draws you in the that you're living in. It's good.
Thanks, Richard. Now, just note we've got about 5 minutes left, I think, in this session. So we'll do 1 or 2 more questions. I want to finish off by kind of asking the panelists, particularly for people starting out on their solar journey, what's their kind of top 1 or 2 tips. But before we do that, quick one, I'm waiting on my first power bill. Do I need to apply for a feed-in tariff, or does that just happen?
Well, as far as I'm aware, the feed-in tariff is just set. I mean, depends on which retailer you go with. Some of them have better than others. So you'd have to hunt around a bit. some will offer above the minimum, but that's set by the retailer.
Great. Another one around costs. Can we predict that solar systems and installation are going to reduce in price due to their increase in their use and popularity? Do we think their costs are going to come down in the future, or do we think that they've bottomed out?
Costs are going to continue going down.
There's going to be a bump up in the next 12 to 18 months because there's supply chain issues there. So I've seen articles saying that the suppliers are pushing the price up to get them here. But I think after that, once the supply chain gets sorted, it'll go back down again as they get themselves organised.
Great. Another quick one. How realistic is solar in regions where cloud cover is prevalent, for example, Tasmania?
Which side of Tasmania? The east or west coast?
It not specific.
Light still generates electricity, just generates a lot less. So typically a heavy cloud day here will drop down to maybe 10% of full sun output. So you're still getting power, you're just not getting as much. So the question is arbitrary, depending on the number of cloud days, the thickness of their cloud, and how much they're able to store when they're making hay whilst the sun's shining.
Yep, and Victoria gets cloudy as well. I'm not sure if it gets as cloudy as Tasmania, but we have enough solar to supply all of our household needs and travel needs too now. And again, it comes back to, you know, a well-designed system and figuring out how many sunny days you have a year and what your needs are. So it can be catered for.
I think the other thing to point out is too, if you're after renewable energy, that's not necessarily meaning putting solar panels on your roof. If you're worried about cloudy days and production from that, buy green power, right? Buy it from hydro, or buy it from a solar farm somewhere else. So I think sometimes looking broader and saying, I really want to be a renewable energy supply doesn't mean you have to have panels on your roof. There are alternatives.
Yeah, good point, Howard.
I could actually, just adding to that too, is the peer-to-peer energy trading trial that we did here at WGV. That's another way. I mean, I think Howard's point's really good, but actually, you know, in some areas, hopefully the grid operator or the retailer might be able to support peer-to-peer trading, and then you can actually use someone like Power Ledger or another company to you know, buy solar off someone else, not just your normal mainstream retailer. I don't know what sort of options people have had over east, but Synergy, our main retailer here, really were positive and supported that trial well in Western Australia.
Yeah, great. Thanks, Martin. We've only sort of got a couple of minutes, so I might throw to the panel generally around, you know, for people that are starting out, haven't done solar before, haven't got it at home, don't have a lot of experience. What's the panelist kind of one or two top tips for people in that situation? Who wants to go first?
As I mentioned before, you know, do your research with who you're thinking of having. So become as informed a customer as you can, so you know something about the subject. I think that's really important. You don't have to be an expert, but just so you know something about the subject. And then you can sort of suss out, you know, what angle, you know, your prospective supplier is coming from and what experience they might have. But yeah, it is important to get an experienced person. And as I said before, when you're asking who we all got to install ours, that Off-Grid Energy Australia has a really good range all across Australia in on-grid and off-grid systems, and a good level of expertise. And having that depth of experience and expertise, I think, is really important in designing a system that suits someone's needs, because that's where it comes from. There's no one fit-all solution. You know, it needs to be designed for what that household needs. Thanks,
Richard. And perhaps 10 seconds from each of the other three.
Yeah, Damien, I think...
Oh, sorry, Martin.
Oh, okay, sorry. Richard, I think that really good points. And then to supplement that, I think it's really good as well to start with, you know, whether you're retrofitting a house or you're going for a new build. If you're retrofitting, well, what are all of the energy efficiency attributes that you can, redevelop into the house, whether it's insulation or gap sealing, or there's so many things that can be done at very low cost. And likewise, in a new build, well, first of all, get everything right in terms of passive solar design, maximum levels of insulation, and so on and so forth, just so that you end up with a really energy efficient home. And then when you do go to select and design and put on a solar power system, you're going to get the most out of it, and it's going to meet most of your energy needs.
That's great, Martin. Thank you. I'm going to have to apologise to Howard and Alan. I think we're going to be out of time on that one, but Richard
One word.
Martin's advice there. One word.
Rebates.
Rebates.
Don't forget rebates.
Thank you, Howard, and thank you to all the 4 panelists. You guys have been great for that session. Really appreciate your advice and experience. Obviously, the panelists' homes are on the website. People can keep talking and asking questions of Martin and Richard and Alan and Howard on the website as well. And yeah, I hope people got a lot out of that session and enjoy the rest of the day.